This is John Black, Super Chemist. Keep in mind, this is not an instructional video. This is a blog or vlog or whatever you call it of me learning this reaction. This is only the second time I've done this reaction. Keep in mind, ether is flammable, very flammable, and I'm sure that the TERT-butyl and all these chemicals are all bad for your health. So if you repeat anything in the video, do it at your own risk. We're here to make some TERT pentyl alcohol. Through a Grignard reagent. And I'm going to go over this kind of quick because I've already done a Grignard reagent. This is my second one. Hopefully I'll do a lot better than the first one. First we have to make the Grignard reagent. Now I made this exact Grignard reagent in a video called ETHYLMAGNESIUM bromide synthesis Grignard reagent. So I'm not going to go into it, but here's the molar masses and molar volumes. I divided everything by 2. This one I doubled by 2 because you need 2 moles. But then I doubled everything by 2, and this is what I'm using. Here's my setup. We got a 1,000 milliliter 3-neck round bottom flask with a condenser on it, and 2 separatory funnels or equalizing funnels. This first funnel is going to have 90 milliliters because I need 104 milliliters to get the ligands, right? That's the bare minimum. So I got 90 and 50. That's 140 milliliters. That's obviously more than I need. I want to have more. So anyways, here's the ethyl bromide. I put 90 milliliters of it in with that, and I put 50 milliliters in for the magnesium into the round bottom flask. Now, when I did my first Grignard reagent, I forgot to put anything in there, and that's good. You need stuff in there because it acts as a heat sink, absorbs some of the heat. The other thing is it acts like a blanket to protect your product that you're making from the oxygen and the carbon dioxide and the water from the air, because those things will react with what you're making. You know what I mean? It'll ruin your reaction. Without that blanket, you're really going to get a low yield. So this time I'm putting in 50 milliliters, cover it up, the metal, and all I'm going to do is drip it in to make my Grignard reagent, which is ethyl magnesium bromide. So here we go. Alright, here's my setup. I did do one thing different. I had to put 100 milliliters of diethyl ether in here in the pot because it wouldn't cover up the metal. The other thing is this is my acetone in that. It was supposed to be right here, and then I'd have a hose coming up to this so that it was like an equalizing funnel. But I got a leak on it, and some of it came down, some of the acetone came down into the reaction vessel. So I took that off, and I'll probably just use this. So what I'm going to do is I'm going to start dripping this in. I'm going to drip in maybe about 10% and let it sit there and make sure that it goes off. If it goes off and starts running, then I'll drip it in so that I keep the temp at like 40 degrees. You know what I mean? Or whatever, 34.6 degrees for the boiling point of the whatever, somewhere around there, 40 degrees. I want it to reflux, but not too much. So I'm going to turn off the camera right now. If you really want to step by step, go back to my first Grignard reaction where I made. The only difference that I'm doing here is I got a lot more. I didn't put anything into the pot with diethyl ether. I just had metal in here on the first Grignard. Bad mistake. Another thing I did different is I have a gram condenser here instead of a regular condenser. And then I have another condenser and a drying tube. I don't know if you can see that. So I'm going to drip this in and I'll get back to you. Another thing I did different is I got a stir bar on here. Probably can't see it. Let me close it up. You can see this is the color I wanted it to be before. Milky. I like that milky white look. It's going up now. I just started dripping it in, maybe 10 milliliters or something. And the temp went up from like 20 to 25 C right now. So I didn't even stop. I'm still dripping it in. and we'll just go from there. Alright, so I got all the ethyl bromide in there, so now I've made my nucleophile, my ethyl magnesium bromide, which is a Grignard reagent. Alright, started the refluxing out at 38, and it took it all the way up to 45. I guess as you make the ethyl magnesium bromide, you know what I mean, it's in there and the boiling point temperature goes up. So that's a good thing. I'm going to let it stir for a while until I see the temperature start going down, and I'm going to fill this up. Because I had it for here, but that set funnel wasn't very good. So I'm going to just add it into here, and then I'm going to drip that into here to make our Grignard reaction. Okay, the acetone and the diethyl ether will be in here, and that's our electrophile. Nucleophile, electrophile. So now we need to make the electrophile, right? This is the equation. We already made this. We're going to add some acetone. This is our electrophile. Why? Because this is electronegative, so it's going to pull electron density away from the carbon, right? You have a positive carbon. Negative carbon, positive carbon. They meet up, and this ethyl group is now on here. Look, there's two carbons, 1, 2. Tagged right onto there. But see, because it's negative, the double bond went up on top of here and made 3 lone pair electrons instead of 2. So it's negative. And then your magnesium bromide is your positive. And this is your tetrahedral intermediate. It's an alkoxide salt. It's polar, so it's going to go into polar solvents, right? Like water. This is the molar mass, density, molar volume, and remember, I'm taking dividing everything by 2, right? I got supposedly half a mole there, so I'm going to divide this by 2, which is 37 milliliters. So that's what I want to add in acetone, but I don't want to add it straight. I want to give it some kind of solvent that it's in, which is obviously going to be diethyl ether. I was going to put 37 milliliters, and then I thought, well, it is the solvent. I want to put at least a little bit more in, right? Plus, I have OCD, so 50 is a good number for me. So I'm going to put 50 milliliters of diethyl ether in there. It's a little bit more than being a 1-to-1 ratio. I'm going to put it into this other SEP funnel, right, and drip it in to the ethyl magnesium bromide, right? This is our Grignard reagent, and we are now going to conduct the actual Grignard reaction, which is this. And then we'll get to this at the end. So I will drip that in and get back with you. Oh, and also you can see that all the metal is pretty much gone almost. Well, that's like 3 milliliters or something I dumped into here, right? From here to the acetone and the diethyl ether. And man, it all just like solidified. You can see. It's almost a big chunk. It's still boiling. So I'm going to let it just sit here. I'm actually going to go to sleep because I'm about ready to fall over. Let me bring one thing up before we get on to the next step here. When I was adding the acetone diethyl ether mixture to my Grignard reagent, right, to do the Grignard reaction, that is very, very exothermic. When I made propanoic acid, I bubbled CO2 in as my electrophile instead of acetone. And it did produce a little bit of heat, but it was no big deal, really. You know what I mean? It barely kept up the temp. The acetone, I couldn't even drip it in. What I have to do is drip a little bit in and turn off the set funnel so it wouldn't drip anymore, let it react, and then drip a little bit more in. Because if I just dripped it in regularly, it was just too much. It was too much. It's very exothermic. Now on my propanoic acid video, when I got done, I had the salt of a carboxylic acid, bromium, magnesium, propanoate, right? Here we have the salt of a tertiary alcohol. So we have salt in here, and what I did was to change the salt into an acid on the propanoic acid one was I put in some acid, right? Here we're going to put in acid too, but we don't want to put in hydrochloric acid like we did for the propanoic acid because it's too strong. It's just too exothermic. So the acid we're going to use is water, cold water. I have freezing cold water here. I have an ice bath here, and my product, you can see it's all solidified in there. I can't even move that thermometer or anything. It's just totally solid. So what I'm going to do is I don't want to put the water in too fast because even with just water, it's very exothermic. I put this gram condenser on here that's not filled up with water or anything, just in case it starts boiling away. You know, this could stop some of it. So what I'm going to do is I'm going to drip this water in very slow. I only have half of it in here. How much water am I using? Well, I'm using about 400 milliliters. Why? Because I had about 400 milliliters in this pot right now. If I had 300, I'd use 300 in water. If I had 200, I'd use 200 in water. Now, is that the correct way to do it? I don't know. I don't have any directions. I'm just guessing. That's my guess, and that's what I'm going with, okay? So I'm going to drip this in, and I will get back with you when I have all that dripped in, plus the rest of the 400 milliliters, and I'll get back with you then. Basically what we're doing is we're changing the salt of the TERT pentyl into TERT pentyl alcohol. We're turning it from a salt, an alkoxide, to the actual alcohol. I just dripped in about 10 milliliters, and I had to turn this off because it started going up to the gram condenser all the way up to here. I was like, whoa, what the heck? So I turned the water on this water cooled condenser, and now I'm going to start dripping it in again. Alright, there we go. Got it dripping. Hopefully this condenser will keep that under control, the heat. If not, I'll just turn it off from dripping for a little bit and let it cool down. Alright, I'll get back with you. I probably put too much water in there because the last bit of it, it wasn't raising the temperature or anything. But that doesn't matter. Too much is okay, too little is not okay. Okay, now I got 30 milliliters of sulfuric acid in here, and then I put water in, so it went up to about 120 milliliters. I'll put it in this SEP funnel, and then I'm going to drip it in. You can see there's two layers. See how the top ether layer? Yeah, getting close. See the top ether layer, and the bottom has the salts. Drip this acid in there through the SEP funnel, and just to make sure that I got everything hydrolyzed, and try to separate this a little bit and get rid of this solids in here. So when I get done doing that, I'm just going to drip it in until I see the solids disappear. Alright, I kept dripping it in until I could finally get my stir bore to go. You can see here, see how it's bubbling up. That's the reaction between the acid and the metal and the salt that's in there. So I still got a lot of, probably only put 30%, 10% or something of that in there. There's still a lot left. But I'm going to hold off until I see this stuff stop reacting. Then when it stops reacting, I'll put a little bit more sulfuric acid, and you can see there's still a lot of solid in there. You can see there's two layers. This is how much is left of that 120 or whatever milliliters I had of the sulfuric acid. You can see up on top there, there's like little pieces of metal. The stir bar is making a vortex there, bringing it down little by little, and as it comes down, it reacts with the sulfuric acid. So I'm going to wait till all that metal is gone. It's going to take a while though, but you can see there are two levels. It is biphasic. Here's the line, and like I said, I'm not going to add any more acid, even if it doesn't get rid of that metal, but I am going to wait, because you can see, I don't know if you can see, but I can see that, like right there, I don't know if you can see that or not. Yeah, you'll see a rocket come by every once in a while. That's the metal.